My name is Wade Wegner. I'm an architect at Microsoft, and today I actually have a panel of some of the customers that I've worked with, and we're going to talk about some real-world applications that they have migrated into the Windows Azure platform. And so the very first thing I want to emphasize is these are real applications. These are apps that these companies have built, that they run today, and they've looked at migrating them into the cloud and what some of the challenges are, and how they've resolved them. And so as they walk through, they're going to discuss some of these challenges and some of the reasons that they actually look to move into the Windows Azure platform. The other thing I want to call out is that between the four of them, we have four very different scenarios. So the very first one we're going to be talking about is an internal line of business app, and looking at what it takes to actually take this application and move it into the cloud and still be able to do the types of things that a line of business system needs to. The second one is actually a set of services that run autonomously and are connected to by a host of different types of clients. The third is actually an e-commerce website, which has a very different profile. So it's an externally facing website, and it's going to have a whole host of different challenges that it's going to have to address. And then finally, we have a transcoding service, and actually taking in media and video and looking at how you actually go through the process of encoding this information up in the Windows Azure platform. And then finally, and I really want to emphasize this, we're going to, as we move through this, we're going to give you all some background into the applications and talk about some of the characteristics of them, but we want to get through this so that at the end we can open it up to a lot of Q&A. So think about the questions you have, and please, at the end of it, come up to the microphones and ask everyone that's up here. And we have four speakers today. So we have Joseph Parody from Accenture, Gurleen from CCH, David from Domino's, and then Mark from Origin Digital. And so they'll be walking you through these applications. So with that, I'll pass it over to Joseph.
Thank you, Wade. So what I want to talk about is the application that we looked at was not really a specific single application. It was more of a common design pattern for the type of web application that we have a lot of, and we believe many other companies have a lot of. I am in internal IT. I'm not an external consulting person, so I'm involved in the running of Accenture as a business. So it's probably similar to what many of you face in the challenges that you look at when you think about Windows Azure. So when we looked at Windows Azure, we wanted to identify what were the types of concerns that a corporation would have about taking an internal line of business application and running it in the cloud. So the pillars of concern that we identified were authentication, how do you know who it is? Authorization, should they be able to get to the app? Data synchronization, so how are we going to get our data up and back? How are we going to keep that data secure? Can we integrate with the other applications that we want to integrate with? And how are we going to do our operations and management of this environment? And lastly, in doing all of this, while it may be interesting to be able to satisfy all of these concerns, if we can't do it cost effectively, then it really makes no sense. Because rewriting a business application to have a payback of 2 or 3 years in hosting costs just doesn't make sense for us or for many of you. So here's what the before infrastructure looked like. This is a prototypical application that we have. We have a user accessing a set of web applications. Those web applications are authenticating against Active Directory, and they're using a SQL database in the back end. So this is a very common design pattern that we have. We wanted to move it to Azure, and in moving it to Azure, this is what it looks like. So the web app runs in Windows Azure. The database is on SQL Azure. And in order to handle the authentication traffic, we use ADFS and passive federation so that there's no copy of the Active Directory up in the Windows Azure cloud. There's no direct connection between the web application server in Windows Azure and our data center. And the only traffic between our data center and the Azure data center is the SQL database that's being pushed up there on a regular basis. You also see here that we have still some applications that live within our data center. So we're not going to move everything to the cloud, we believe, and we're still going to want to have a good experience. ADFS and passive federation gives us that opportunity to have the seamless experience for the end user, but also have a choice of our execution architectures. So what did we find? I'm going to go back to those pillars of concern. So in authentication, we found out that by leveraging ADFS and passive federation, we were able to get the authentication we wanted against our corporate AD, but without having to move that data or the traffic to the Azure data center. With authorization, by using the claims-based authentication model and using Windows Identity Foundation or Foundation, we were able to make the authorization decision at the web tier in Azure without having to have a connection to the Active Directory. We used SSIS to push a subset of our rows and columns from our corporate data table up to the SQL Azure instance. SSIS is a technology we're very familiar with, and we were able to reuse a package that we already had that moves a similar set of data between one data center and another. Security and audit was something that we found is going to differ by organization, by industry, by country sometimes. And we weren't comfortable that yet we understand enough about how security applies to different types of data that we might hold and how we satisfy those concerns in the Windows Azure cloud. So we're still looking at that. Our IT security team is looking at that. But we started down that journey so that we'll be able to understand at the point in time when we want to be able to move substantial applications to the cloud, what that's going to take and how we satisfy the concerns of the other organizations. For application integration, we found that the ADFS passive federation model worked really well for web single sign-on. So you go to application 1, you sign in, you go to application 2, you're not prompted again. So that worked really well. It was what we wanted for our end user experience. What we still need to look at is how does that work for web services, right? How do you delegate that authentication through to maybe a web service that's running inside from an application that's on the outside? In the operations and management area, we found that we really couldn't use the model that we were using right now. So we have event handlers that handle the events, they handle the exceptions, they write it to the Windows event log. We have SCOM custom management packs for our applications. They pick up the events written to the event log and then fire alerts and emails off to the application development team. Well, those things don't exist in Windows Azure. At least not when we were building it. Some of the announcements this morning changed some of what will be possible in the future. And so we're looking to understand how we can get the same type of functionality that we want to give our stable operations and running in Azure. The cost factor was really interesting. We had very little code change to our application. This was a NT token type of application. It took about 10 lines of code to change it to claims-based authentication. Changing the connection string was literally one line of web.config. And other than that, we didn't have to change anything in the application. We were able to get this running on an environment that's a lot less well documented, shall we say, than it is today. So this was a few months ago, in less than 10 days. So this is something where it met our goals of saying we have to change only a small amount of code and we can do it quickly. So why do we think this is cool? It leverages the skills that you already have, that our teams already have. We didn't have to really build anything, right? We use ADFS today. We think a lot of companies are going to continue to look to ADFS for that model. And we didn't have to build anything, so it was right there. We didn't have to worry about the plumbing. This was a big deal for us, right? We didn't have to worry about how to configure the IIS or how to spin up another instance. We just had to write the code. And then finally, we found even in the CTP work that we did that the tools and the guidance were there for Microsoft to help us be successful. So now I'm going to turn it over to Gurleen, who has a very different example, which is more around a pure service model in the cloud. Gurleen?
Thanks, Joseph. All right, so for CCH, essentially, to talk a little bit about what the product was, it's called Sales Tax Office. It's an enterprise-level calculation engine, a sales tax calculation engine. And currently what we have is it's an on-premise solution. So if a customer buys it, they need to install the solution on-premise, and then they have to maintain the hardware and the maintenance and everything. So the logical step for us was to basically make it into a software as a service solution. And at that time, the TAP program opened up for Azure. So it was very apparent that we wanted to use that opportunity to look and see how we could move our application into a SaaS model and use the Azure cloud for that. Now, the advantage to the customer is if they go to the SaaS model, they don't have to worry about basically the hardware. They don't have to worry about maintenance. And from us, from CCH perspective, we can always amount of the load that we're getting on our system, we could basically provision the VMs from Azure Cloud, so we don't have to do basically planning and have a lot of hardware being wasted away. And not only that, the maintenance cost of software updates, and if you have any OS updates, so all these things would be taken care by the Azure Cloud itself. So it made good business sense for us to go this way. So like I talked about, so SalesX Office, it's a real-time sales tax calculation engine. Essentially, there are three basically main parts to that. There is a database, which is what we call rates and taxability, which has all your rates and the taxability decisions in it. Then there is a business logic calculation engine, which uses that database. And then third, there's an admin module to that. So what we had to see is how we could take all this infrastructure and kind of move it into the cloud. Another interesting thing in this whole project was we use a tool from Computer Associates called Plex. And it's a 4GL tool in which you don't write code, you just model everything. And then the tool itself generates the code for you. So essentially, we were trying to take something which is machine-generated code in C# and see how we could easily port it over into the Azure cloud. So this was the original architecture with everything being run on the client's premise. So we have the database at the back, and then we had a web server essentially, which is hosting web services. And then you have web clients connecting through that and consuming the service in their own applications. And the applications that we deal with are enterprise level applications like Dynamics ERP products. So we hook into Dynamics AX, GP, and Nav, and certainly you could hook into any other ERP as well. And then the second part is the app server essentially, which is the admin module. So again, if you're going to use the service, you have to set it up, and that's what you use the admin client to set it up. So what's in the cloud? So what we did is we took our database and the web services piece, and then we kind of moved it into the cloud. So now you can have a client which is essentially still in premise. So let's suppose they have an ERP solution, which right now they can't move to the cloud. They could still, from their premise itself, connect back to the services and consume them and do their tax calculations from there. The admin client and the app server, they're still residing in the premise itself. Again, it's going to be not that hard to move them into the cloud as well, but that's work in progress. So that's what it's going to, or what it is right now, and we have shown with AX it's working pretty well. So the challenges, one of them I talked about, it was Plex, which is a third-party tool, and we don't have real access to the source code. It's machine-generated code. But certainly we didn't have to make too many changes to that. We just had to make one small change, which is going to be very interesting for all of you people here as well. You really have to go stateless, because with, let's say, SQL Azure, if your connection is idle for 5 minutes, it's going to get broken up automatically by the system. So the way our architecture was set up, we had basically a connection set up from the services to the database. So we had to change the code a little bit every time a call comes in. Now we have to make a connection every time. State management, so basically ties into that. Make sure that you don't assume too much because it's a virtualized environment, that your state can be broken at any time. So make sure your solution is robust enough to deal with that. Performance, right now our solution is on-premise based solution, right? So everything is inside your own network. Now you're going to make calls to the cloud. So not per se related to Azure itself, but anytime you're going to make it into a SaaS solution, which is going to be hosted outside the customer's premise, you have to make sure you look at the performance and make sure it meets your SLAs with your customer as well. So very important thing to note of as well. Security, right now our solution was built to be run within premise. So again, security was there, but not to the level that you would really want. So the time frame that we had for the TAP program, we used 509 certificates, and we basically using message level security. So we basically take username, password, send them to the back to the servers. And then at the server, again, because it's in a cloud which you don't own, so we are just storing the hashes of the username and the password. We don't store the actual username, so that's going to be another important thing. If you don't have control over the hardware, you might have to do something about storing these things, which you should do on premise as well, but it makes more sense, at least to make sure you do it on the cloud. Database migration, we had a little bit kind of problem with that because the database size was huge, but I think SSIS, it works pretty well with the cloud, so I think it shouldn't be a problem at all. The last concern that many people are having is the database partitioning. As you know, with the Azure cloud, there are 2 SKUs for your database. One is a 1 gig SKU and another one is a 10 gig SKU. So if your application is built in such a way that it's going to consume more than 10 gigs, then you need to make sure you look at how your database design is done and look at if you need to partition it so that the overall growth of 1 DB doesn't go over 10 GB. So very important consideration that you might have to look at, especially when you're trying to port existing applications in which it wasn't such a big consideration. So lessons learned, the first big one is if you had control over your hardware, now you don't have that. So again, for some people, it's a big thing. I don't have control over the hardware and the software. But lots of services and APIs are being built around, so you have good insight into what's happening in the cloud for you. Log, again, everyone needs to log, but again, you are in a cloud. So again, I would say what we found out very useful was do a lot of logging, because that really helps you what's happening on the cloud as your applications are running. So it's for performance basis, it's for making sure your asserts are going through. So we did a very simple thing. What we did is we took a database table in the SQL Azure cloud and we did all the tracing to that. The advantage of that simple approach was we could just connect locally from our SQL Server Management Studio onto the table and just write queries and see what's going on. Now with, I think the release of basically Azure, I think lots of things are being done around logging. So I think you would have lots more tools than what we had when we started using the cloud. And another thing is going to be, right, people have been kind of scaling up rather than scaling. You want to scale now horizontally rather than vertically, because you won't have one box in which you can keep on putting more procs and more RAM, right? You need to start designing your application so that it's horizontal scaling. So start thinking about that, what kind of changes your applications would need to make in order to make sure it can realistically kind of scale horizontally rather than vertically. Again, the last one, another one is the database partitioning that I already talked about. It's a 10 GB limit. Be careful about that. And plan your data migration. Again, and that's going to be if you have an existing application that you want to move from on-premise to the cloud. If you're building from scratch, you might not have to, but another thing to be considerate about. What we found is, again, that we would rather keep the sensitive customer information on-premise rather than on the cloud. So for that, you have Service Bus, which is a very good way of connecting your on-premise solution with your solution on the cloud. So certainly look at Service Bus, and if there is some information that you do need to keep on-premise, you can use this approach, and it works pretty well. With any solution which is going to be on the cloud, make sure you start thinking stateless. And I think that's going to be a big difference. People have been thinking a little bit about stateless, but you have to be very careful here. Don't assume anything. Always think it's going to be stateless, because you're working with virtual machines, and your state you have to manage in a very different way than what you might have been doing till now. And with that, I'll turn it over to David from Domino's Pizza, and I think he has a good solution as well.
Thank you.
Sure.
Okay, so I'm from Domino's Pizza, and we're looking at Azure as a place for hosting our e-commerce website. So why would we be looking at Azure? Well, here happens to be our usage graph of our hits to our website, with each of those humps representing a day of the week. Monday on the left, all the way to Super Bowl Sunday on the right. And as you can see, is that we have time periods where we actually have almost no activity going on our website. And we have other times we're getting lots of hits on our website. Super Bowl Sunday represents a special challenge for us because it's the one time of the year where all 4 time zones are synchronized. Everybody's ordering at halftime. Throughout the rest of the year, we've got time zones, so we can pretty much spread out. We got our business somewhat spread out, and so we don't have quite that peak. But on Super Bowl Sunday, you know, like in New York City, everybody flushes the toilets at the same time and causes problems. We get a lot of orders on Super Bowl Sunday at the same time. So our current architecture is a pretty traditional architecture. We've got a web tier, we've got an app tier, we're talking to a relational database, and then we have a VPN which connects to our 5,000 stores. The interesting part is that we run Java under Tomcat as our web server on a Solaris operating system. Our database is an Oracle database. So, you know, some of you are out there saying, heretic, what are you doing here? And our VPN is a Cisco hardware-based VPN out to our stores. But our stores are a Microsoft-based solution, so there is some redeeming quality, I guess, in our infrastructure here. So what we want to do is we want to take that architecture and we want to be able to run that architecture both in our own data center and also in the cloud. So we want to do some fancy graphic stuff like this. Where the top part would represent what's in Azure and the bottom part is what's in our data center. So what does that mean in terms of how we need to modify things? Well, because Azure supports Java, we can migrate our web tier and our app tier relatively easily up into the cloud. But we do have connectivity issues. We can't move our Cisco-based hardware into the cloud. So we have problems getting the orders to the store, which is a big problem. But in Azure, we've got the .NET service, or what's now just called the service bus, and we're looking at using that as a way of connecting to the stores. So literally, our stores would create a connection up in the cloud that we will then use to get the orders down into the store. And this basically simulates our VPN connection. But we also have another problem in that our relational database is rather large, and it's a hotspot in our current architecture. So if we wanted to try to continue to use a relational database, we'd have to do some serious sharding of our data in order to get it up into Azure. So what we decided to do was to bite the bullet and say, when we're up in Azure, let's use Azure storage, so they're key value storage, either blobs or tables. And then what we will do is we will simulate something similar in our own data center. Our application really seems to fit well with being able to use a key value store as a way of storing our data. But we still have some differences that we have to account for in our architecture. For instance, logging is a little bit different between the two. If we log to the file system in Azure and the machine crashes, we don't have that data anymore. So we need to handle the logging differences. Obviously, we're going to have storage differences. If we're running some other sorts of key value technology within our data center, we also need to be able to have a similar kind of interface to get to the key value store up in Azure. And finally, we got some connectivity differences in how we're actually talking to the stores. So how do developers deal with problems like this? A layer of abstraction. So we've essentially written our own little connectivity to get to Azure technology, but then we can also plug in our own technology if we're in a different environment. So we essentially wrote our own equivalent of a little ODBC kind of driver to get to key value store. You'll find it's rather simple to do. I need to be able to get, I need to be able to put, and I need to be able to delete. And you find that you can pretty much wrap up most services in that kind of a simple interface. And that's what we did in order to handle our storage technology. So takeaways. Java does run up in Azure for the 1 or 2 people out here that might be interested in that. The service bus does provide connectivity, a VPN-like connectivity, into something like stores or into other environments. And we find that the Azure storage technologies are easily abstracted. So with that, I'd like to turn it over to Mark, who's going to talk about his video transcoder.
Thank you, David. So Origin Digital is a video application service provider. We provide video services to other companies, be it live streaming events or on-demand encoding, content management, et cetera. And, oops, wrong button. You'd think the button on the right would go to the next. What we wanted to do here was, first of all, be able to decrease our transcoding costs. Today, we use several different on-premise transcoding solutions, and some of them are expensive, some of them aren't so expensive. We wanted to provide better scalability, and we also wanted to be able to provide better geographic distribution. And our key factor really was being able to respond quickly to customer demands. So be able to respond to the changing number of files that we're receiving from our customers. So the way our system works today is you've got the nice little lady on the left. She goes to XYZ Corporation's website, and she chooses to upload a file and submit a bunch of metadata. That goes through our adapter file upload, and we have several different ways to receive files: HTTP post, iframe, Silverlight, Flash. And the file is uploaded and loaded into our adapter system, which has our content management. We then do the video transcoding, and we deliver the output files out to the customer's location, typically a CDN, and we do a postback of that data to the XYZ Corporation, letting them know exactly what we created, where the files are, all the metadata that came from that user. So we had to really rethink the architecture in order to get this on the cloud. So what we have is essentially 3 roles running on the cloud. The first is our web role, which is our file upload. So now the user uploads the files and they go right into Azure. They never come into our on-premise solution. And that means that we can do the geographic balancing that I talked about earlier. We can have a data center in Chicago, we can use one in Europe, we can use the one in Asia, and receive the files. Once the file is received, we communicate back with our adapter system and let it know that the file is received and the metadata that we have about it. And we then put a message onto a message queue in Azure, with the information about that file. Then we have our manager worker role. That guy wakes up every once in a while, checks the queue for new jobs, and communicates with adapter and figures out what exactly it needs to do for the transcoding. And it puts a different set of messages onto another queue that tells the transcoders exactly what they need to do. Then we have the transcoder worker roles, and this is the dynamic part, where we can control the number of roles that we have, the number of instances. Those guys wake up, check the queue, they download the file from the blob storage where we stored it when it was uploaded, does the transcoding, and sends it off to the customer's location, to their CDN. And it updates adapter and lets it know that the file exists. So we were able to manage this cloud infrastructure just by using web service APIs into adapter and take advantage of all the features. So some of the challenges that we ran into was, first of all, finding a good software-based encoding solution that would run within Azure and was cost-effective and fast enough for us. The next was determining algorithm for auto-scaling of the number of instances. So like Domino's, we have peaks. People tend to upload a lot of videos right as they get off of work for the UGC sites. For our corporate customers, it happens, in the morning, et cetera. So we have a lot of peaks. We have daily peaks. We have hourly peaks. And we wanted to be able to auto-scale the number of instances that we have so we can control our costs. And as has been alluded to before, working with pre-release software from Microsoft on this has been a challenge because it tends to change over time. And sometimes those changes break your code. And then for us, one of the difficult things has been the deployment and release process. Because of the way our system works, checking queues, my development environment can't be looking at the same production environment and the staging environment, all that. So the deployment process was not easy. But the benefits are significant cost savings for us over the on-premise transcoding solution that we use today. Partially because we're not paying a license fee for that transcoding, and also because we can control the number of instances and match that to our volume. The ability to, as I said, quickly respond to the changes in volume, and the ability to be geographically relevant. If you've got a user in Singapore, you don't want that file coming all the way to the United States to get transcoded and then back to Singapore. It'd be nice if that could stay over in Asia. And I'm going to turn it back over to Wade for the Q&A.
Great. Well, like I mentioned in the beginning, we very much want to answer your questions. So we've left 15 minutes at the end of the session. So please feel free to come up to the microphones. and ask any questions you have. As we're waiting for you to come up, I just want to mention that it is very important that we get your feedback. So we think it's valuable to bring customers here to actually talk about the solutions they've built. And your feedback helps us so that we can continue to do that at other events. And I think also one of the things, and I don't know the exact specifics, but for every evaluation, I think Microsoft is also making a donation. So I really, really highly encourage you to do so. So with that, love to take your questions.
One over on
Hello. Hi, guys. Great session. Thanks for the tips. I have a quick question. I know that Windows Azure is going into production mode on January 1st, but have you already gone live, going through the current staging and then deploying to production system?
So for us, we have not gone live yet, right? There are some more business-oriented reasons for that than technology-oriented reasons, as I mentioned in the presentation.
Right. And I think that the same thing applies to us as well. We've seen there are lots of cost savings for the customers as well as us if we go to the cloud. But certainly there are few things, as we have been working with pre-release SDKs, right? We want to make sure we can polish everything up before we go live. So certainly it's an evaluation stage right now, but mostly it's going to be business as well as the business unit going to take that decision, plus something polishing that we still need to do.
And we're on track to go live. We still have a few more things to do, but we hope to in the next quarter.
We have not gone live yet.
So follow-up question, do you know from Microsoft's perspective, do they have a go live license? Is it, if somebody wanted to go live today, could they go live?
So as was alluded to in the keynote this morning, come January is when we actually will start offering the ability to go live, and then come February is when the billing cycle will actually begin. So
if I deploy something today, then...
So the CTP remains in effect through the end of the year. So.
Okay, thank you.
Yep.
In the center?
Yeah, this is really for your tax application. You talked about some minor changes you had to make to the system, like making it stateless and making it scale out. Those they don't sound to me like minor changes. So can you tell us something more about what was involved to do that re-architecture?
Our application, the tax application, it was already built using web services. So that's why the changes weren't that drastic. If it was, let's say, a connected TCP/IP kind of connection, right, then we would have needed a lot of different changes in the system. So that's why I say relatively small. Now, our biggest thing was we used Plex, which generated all that code. So that's where our big, I think, risk was, because frankly, it's machine-generated code, or your classes and variables are named class 1, 3, 4, 5, right? Doesn't make much sense, so we couldn't go in and make changes. So one concern that we had was the database connection. Essentially, it was set up so we would make a web call, it would look at a pool, and then it would just say, well, oh, I have this database connection kind of cached up, I'm going to use that. So we had to break that connection so that every time you came in, you went in and then just made a new database connection. So in a nutshell, that's a big. Now what we haven't put in yet is the security piece, like I talked about. We started using basically certificates and using message level security, but still that has to be beefed up a little bit more.
In the back, in the center?
Yeah, I had two. Is this on?
Yep.
I had two questions. One is for the Domino's implementation, and that is, what was the decision to co-do it? I mean, the other stories I've heard, you either do cloud or you do on-premises, but you're the first time I've heard of actually doing both. I was wondering what the thought process there was. And the second question is actually for the whole group, which is, how much hand-holding from Microsoft did you have during the design and implementation of moving your stuff to a cloud?
Yeah, we wanted to be both in the cloud, and we wanted to be in our own data center. One of the reasons for that is that because this app is so critical, we wanted to be able to be in multiple places. So if something should happen to Azure, we have a backup place. So we need to be able to run somewhere else too. The other reason has to do with we're already running in our own data center, and so we didn't want to abandon that as a platform. And what was the second question?
How much hand-holding did you get from Microsoft?
How much hand-holding?
Yeah.
They didn't do any coding for us, but they were there to answer our questions when we ran into problems, especially with the cycle of them releasing SDKs periodically. It was often necessary to say, hey, something was working and now it broke. So the usual stuff.
Right.
Yeah, I concur.
Right. And I think for us, another thing was it wasn't a one-way road, it was a two-way road. So we participated in SDR as well. So we told them these are the things which we think you should try to put in the system. And some of the things that you've seen this morning talked about were the things that we have talked about to Microsoft in the last few months. So it's been a two-way road, communication on both sides, which is going to help everyone.
Yeah, we had some help, and again, it was both ways. I had a lot of experience in the federated identity space, and so I was able to bring that to the table, and then they were able to help point me in the right direction. And one of the things that I think is remarkable is the level of information that they had already in blogs and SDKs that we were able to use as reference material. So I'm not, generally a big coder. I'm more on the infrastructure side of our business generally, and I figure if I can do it, probably everybody in this room can do it too. Thanks. There's one over on the side there.
Susan? Yeah. I think Gurleen made a comment about the performance to be taken into account, and it probably applies to all of you. Did you do any measurements as to the difference in performance after you move to the cloud?
Sure. It's never going to match on-premise for sure, right? Because now you have the server. It depends, even on-premise, how your structure is set up, right? If you have good servers, if you have 1 gigabit connections between your server and the client machine and they're sitting side by side, well, certainly it's very hard to match that. So what you have to do is try to match up. If you did a SaaS solution and you put it in your own data center, how does it match up to that? And when we already have our foundation product, which is a SaaS-based solution. And when we did comparisons, it matches up perfectly well. But again, if you have a solution which is on-premise, and again depends upon your SLAs, it's one thing that you have to keep in the back of your mind whenever you go into data, kind of put things on the cloud, right? It might be your private cloud, it might be Azure cloud. So certainly things to look at.
Yeah, for us it was a different scenario in the sense that our users were remote from our facility anyways. So it was actually an advantage for us to be using Azure because they have much larger pipes than we would purchase internally, much larger data centers than we would purchase internally. And we found one of the interesting things was at the very, very earliest stages, we would see that our application would run a little bit slower when hitting it in Azure. Now, within the last month or so, the performance is absolutely the same as running it in our data center. So they've been improving their environment over time. And for our users who are all remote, it's completely transparent. And we're expecting that we might even get a bit better performance just because they have a bigger network pipe than we do.
And for us, the video transcoding is obviously very CPU intensive. So I did a lot of testing early on comparing Azure performance to other cloud solutions as well as doing it in-house and found it very comparable.
Yeah, we haven't done a whole lot of performance-based testing yet. We've been sort of focusing on just getting the functionality to work.
Great. Okay, there's one on the side of here.
Two questions really. We were hearing yesterday in one of the workshops, someone on Ticket Direct from New Zealand, they were deploying into SQL Azure and they were finding something a bit like a query governor that would kind of sort of time out their SQL Azure queries fairly non-deterministically as far as they could work out. I would just, some of you didn't use SQL Azure, but for those that did, I was wondering whether you sort of bumped into that and how you got around it.
Right. I think there is a 5, if I understand right, it's a 5 limit. So after 5 minutes, your transactions would be cut off. So essentially, you need to take your long-running transactions and break them into manageable paths. And that's one thing I talked about when we were working with Plex, right? We were caching the database connections, which would get disconnected after 5 minutes. So we had to change a little bit on that part, saying that you can't cache database connections, one, because they're going to get lost after 5 minutes. Then look at any long-running transactions and see what makes sense. How do you make them smaller? Which in general is a good thing to do, doesn't matter, right, if you're going to the cloud or not. But it's much more important to look at all those considerations right now.
Yeah, for our work, the query transactions were very fast, so we never ran into that. But in the SSIS packages, we did have to make sure that we accounted for the latency, because you're not moving data across your data center network, now you're moving your data across the public internet, and you're going to have an uncertain amount of latency there.
And real quick, gentleman right behind you, actually, George Huey, is authored the, I don't know if any of you have used the SQL Azure Migration Wizard, but he built a service that helps migrate your schemas as well as data into the cloud. And I think, George, did you want to say a piece on that as well?
Basically, I wrote the SQL Azure Migration Wizard. So if you go out to SQL Azure migrationwizard.codeplex.com, you'll find it. And you'll also find the source code there. And what I did when I was migrating data, first off, I used BCP. And so then I was using BCP to upload it. And then I ran into the issue that you were talking about. And I thought at first, I go, oh my gosh, I was loading up constant data. And I thought, okay, SQL Azure won't kill me as long as I'm doing constant work. And that's not true. Part of what happens is that it's taking your data and replicating it in 3 different places. And so then it gets to a point where it can't keep up, and it'll stop your connection at that point in time. And then your code's got to be smart enough to do retry logic. So in other words, when I get the error, I go, okay, I got to do some more stuff. So with the BCP, I get the last number of records committed, and then I start there. So I start doing chunking and some other kind of stuff. And I also put like a 15-second pause between chunks to give SQL Azure time to do some stuff. And I found the same thing as well as when I migrate your schema. If you got several thousand tables and stored procs and other kind of stuff, that takes a long period of time. And I'm in a constant loop. And even if I disconnect for a second and connect for a second, I still would get the timeout. So again, you got to have the code in your code that's smart enough to say, oh, I got an error and I need to retry. And so my point here is for everybody is that I already worked at a process, did a lot of that code. If you're interested, go out to the Codeplex and you can find my code. You can copy and paste and see how I did my error process.
Great. Thanks, George.
Great.
Just out of curiosity, real quick, can we get a raise your hands if you've used the SQL Azure Migration Wizard at all? Is there anyone here? So we actually do have some hands up. That's great.
Great. In the center?
Hi. Yeah. My question is about disaster recovery. So we saw a lot of solutions, which looks great, but I didn't see anything about any existing disaster recovery architecture in place that you thought about migrating as well going forward. And I have another question regarding the queues as well. When you deploy your stuff, how you manage the existing messages in the queue later on.
So David, you had talked
Yeah,
about
well, that's sort of part of the reason why we decided we needed to be in 2 different places. Why we need to be in our own, why we need to be in Azure and why we need to be in our own data centers is just because we wanted to have that disaster recovery ability. Now, we didn't really get into how we're going to migrate data between the 2, but certainly the more we can get our data up into Azure, the better the locality of queries are going to be versus pulling it all out of one place. And we have some data that we can replicate very easily like that. Other data we're likely going to have in one place and then take other forms of disaster recovery for.
And to a certain extent, I won't call it disaster recovery, but when you put anything in the cloud, right, you're getting 3 copies of the same data. So the probability of something going wrong becomes a little bit less, especially if your data is copied over into different geographical locations. So you get a certain amount of, I would say, disaster recovery by default by using the cloud platform itself. But yeah, you certainly want to build on top of that and make sure you have a good plan around it.
My understanding is it is in the same site. It doesn't go copied across geographical places.
I think databases, they don't have to be in the same location, right? They can be spread out. So the point is you don't know where they are, but what I'm trying to say is you do get 3 copies, right? So that means previously you had nothing, you just had one database that you were working off. Now at least you're getting 3 copies, so it's not a full data recovery model, but something that you're getting from the system that certainly you need to build on. I'm not saying it's the final thing all, but at least you get something.
Yeah.
I think Erlene's saying too that the 3 copies are within one of the database or one of the data centers as well, right? So not replicating trends data centers. Certainly something that you could build out yourself, a service to do that.
Yeah. One of the things for us that was important, and they mentioned it in the keynote this morning, was if you can have the application code and database schema, stored procs, and everything work exactly the same on-site as off-site, then it gives you that ability to have a recovery in case Azure were to go completely away, which we feel is probably less of a risk than our own data center going completely away, right? We could still run that exact same application, get it up and running inside our walls if we need to. And so it's part of our overall disaster recovery view that we look at every application and understand what's the risk, what are we willing to spend to reduce that risk, right? But having one set of code that can run both on-premise and off-premise is extremely attractive for us.
All right, I think, do we have time to answer that one last question? So we're out of time. Did you want to address the queues real quick?
Yeah, what was your question about queues? I'm sorry.
How you handle, when you do a deployment, how you handle the existing messages in the queue in the production environment?
Well, for me, if I do a deployment and there's messages in the queue, I just pick them up and process them because they're leftover jobs that didn't get finished. For us, we want our deployment to be up 24/7 and processing jobs. But you certainly could, when your application starts, it could go and clear out the messages out of the queue if that's what you wanted to do.
So do you handle versioning, for example? Can you have two different versions of the application running in parallel?
Yes, you can. You can. There's the staging and production, so you could do that and use 2 different sets of queues. And you could also have multiple projects within Azure. One that is, your QA project, and one's your production, and have those pointing to different queues.
Well, thank you all very much. I know there's a few other questions. What we're going to do is, so that the other groups can get set up for the next session, we're going to walk outside and stand around outside. So if there's any other questions, please feel free to come up and join us, and we'd be happy to talk to you. So, thanks.